Welcome back to this presentation from Coding Bootcamps. This course is the Introduction to Java Programming Language. Again, we are still in session 5, writing methods. Here, we are going to talk about the method call stack. For what we will be doing, there are two sections of memory on, well, as far as Java is concerned, there are two sections of memory. There's the stack, and then there's another section of memory called the heap. The stack is where references are made to objects, and the heap is actually where the objects are loaded into memory, and all of the methods and data are all kept separately in memory. So the stack keeps track of all of the active methods. So as we are working with them, the stack is pointing to the section of memory on the heap where the current object is. When a method is called, a new stack frame for it is added to the top of the stack. So then as soon as we call it, it goes to the top of the stack, and then space is allocated as needed. When a method returns, so when a method of an object is returning, its stack frame is removed from the top of the stack, and then that memory can actually then be deallocated. Space for local variables and parameters only exist while the method is active. And as soon as that method becomes inactive, local variables and parameters, that memory is released. And local variables and parameters are only in scope when they are at the top of the stack. As soon as something else comes to the top of the stack, that memory is released for the local parameters and local variables. So let's take a look here at an example. So here we can see we have a class called foo, and we have a class called test method calls. And there is one main method, and this main method here is instantiating, well, the foo class. So we can see it here. We're instantiating, we're declaring foo, and then we're instantiating it, and we're passing in different, we can see here we're passing in an integer here for our constructors. And then we are actually calling a set value and an add on object F1, or which is of type foo. So let's take a look here. So we can see this here executing through here. We can see that our integer x is equal to 8, so that gets put in the stack. So here is the stack, and here is the heap here. We created these two objects, so we have the reference to the two objects right here in the stack, and then we actually have the objects loaded into memory here on the heap. So the stack is actually pointing to the corresponding foo objects, the data, and all of the methods as well. And when the main calls F1 set value, so you see F1 and you can see set value here, the stack frame is added and it holds the values and parameters of those local variables. So right now the stack is maintaining these local variables right now. And implicitly, a reference to the object referral to and by F1 is passed as well. So the set value was called from within the object, so its members are in scope as well as all the parameters and variables. So right now, we can see here this F1 and this object is on the top of the stack. And we can see here, this is just showing that we are accessing the data from F1, which happens to be of type foo. And when this main method calls add, we are passing the value of the object reference F2. So we're passing F2 in here into the add, and that adds parameter F refers to the same object as F2. So we can see right here that now we have this new item on the stack here, and it's pointing back now to this other object that we instantiated here in memory. And if a method changes the value of a parameter, it does not change the argument's value. So we can pass an argument, but and the method will do some updating, but that argument will always keep the same value. So we are going to take a little closer look at this in the lab. But for right now, the biggest takeaway here is there are two sections of memory, the stack and the heap. And as objects are being referenced and being called, the stack is managing how that operation happens. And the stack, when we are instantiating objects, that instantiation, that name is held in the stack, and the stack has with it, we say pointing, but it has that memory of where that object is actually living on the heap. So we can see here that if we have f1, which is of type foo, we see here that x, this integer x here, is set to 8. And we can actually call these methods and make updates. And you can see here for this method, for this foo or this object here, x is actually equal to 12. So that is the memory functionality in Java. Now, sometimes we talk about memory leaks. Well, memory leaks happen sometimes when there are no more, or there's a deleted reference over here, or no longer a reference remains here in the stack, and also it maintains its it maintains the memory here in the heap. And because we keep the reference, we don't delete the reference, the memory stays taken up. So we sometimes hear there is garbage collection in Java, and that's true, but certain conditions have to exist before that garbage collection is taken. So if we ever deleted F2, and in our lab we'll actually run a delete, eventually the garbage collector would remove this object from the heap, but that doesn't always happen. Sometimes these references remain. Again, we'll get our chance to work with some of this on the lab, and stay tuned for the next video.